Okay, good day everyone. You're welcome to the mathematics class again with Overs of the Eminent Academy. So today we'll be looking at the types of equations, expressions, and inequality that we have. Expression and inequalities. Oh, I explained earlier in one of our videos that when we have mathematics, we can only treat one of these three things. And I said we have some things that we call unknowns, which can otherwise be called variables. And I said to these unknowns and variables, two things are attached, which are the coefficients and their power. So today, we want to look at what are the basic types of these three that we can have. Don't forget that in that video I explained that if something has an equality sign, it becomes an equation. If it has one of the inequality signs, less than, greater than, less or equals to, greater than or equals to, then it is an inequality. While if it has neither of this nor this, then it is an expression. So we can actually name this with one of these things. The very first thing we can use in naming the equation, expression, inequality is the power. The power. If you can recall, I said that when we talk about power, we say power is what we have on top of either the variable or the number, like having x to the power of 4. Now, so if we now have any of these things, okay, let me talk about, we have this 4p cubed minus 6p squared plus 7p minus 1. I have 4p cubed minus 6p squared plus 7p minus 1 equals to 0. I have 4p cubed minus 6p squared plus 7p minus 1 less than or equals to 0. Now, it is clear that the first one is an expression, this is an equation, while this is an inequality, right? Okay, so that being clear, each member of this expression, each member of this equation, each member of this inequality are all called terms. They are called terms. So in this expression, I will say the first term of the expression is 4p cubed. The second term of the expression is minus 6p squared in that respect. So the highest power of the variable known, the highest power of the variable in either the expression or the equation or the inequality is then called the order of it. So if I'm asked that what is the order of this expression, I will say the order is 3. What is the order of this equation? The order is 3. What is the order of this inequality? The order is 3. Right? So the order of an expression, an inequality, an equation, the order of an expression, order of an equation, order of an inequality is the highest power of the variable there. So we now want to name these expressions, these inequalities, and these equations with the order now. So anytime we have an equation or an expression or an inequality whose order is 1, it is called linear. So when we have an expression or an inequality or an equation with order which is 1, we call it what? Linear. But when the order is 2, we call it quadratic. When the order is 3, we call it cubic. It's called cubic. When the order is 4, it is called quartic. It is called quartic in that respect. Now, all these that I'm talking about now, they are in that respect, we have a general name given to them, which is called polynomial. We call them polynomials. We call them what? Polynomials. So in a polynomial, we can now say that a linear either equation or a linear expression or a linear inequality. But let me major on equation for now. Let me major on equation because that's what we're treating most. So I can say a linear equation is a polynomial whose order is 1. A quadratic equation is a polynomial whose order is 2. A cubic equation is a polynomial whose order is 3. A quartic equation is a polynomial whose order is 4. Now, so if I now have something of this nature, 4m minus 6, I have 4m minus 6 equals to 2. I have 4m minus 6 less than 2. So this one will be called linear. Why? The variable here is m and its order is 1. That is linear. But what type of linear it is? It is a linear expression. Why is it linear? It is linear because the order is 1. And why is it an expression? It is an expression because neither of the equality sign nor the inequality signs can be seen there. Why for this? It is as well linear. Why? The order is 1, but it is now what? An equation. It is linear because the order is 1. It is an equation because we can find inequality there. We can find equality sign rather. Why this one is also linear? Because the order is 1, but it is now a linear inequality. So that's how we name these things. Why if I have something of this nature, 3p squared minus 4p plus 6 less than or equals to 2. This will be called quadratic. This is quadratic. And if you are asked, why is it quadratic? It is quadratic because the order is 2. But what type of quadratic is it? Is it quadratic equation, quadratic expression, or quadratic inequality? Obviously, it is quadratic inequalities. So this is one way of naming these our entities, the equation, the expression, the inequality. You can have linear equation, you can have linear expression, you can have linear inequality. You can have quadratic equation, you can have quadratic expression, you can have quadratic inequality. The same thing as for quartic, cubic in that respect. Now, so another type of equation that we can have, apart from this, if we name it with respect to the number of powers, the highest power it has there, apart from this one now. You can also name it, you can also list the types of equations, expression, or inequality we have with respect to the number of variables we have there. Number of variables. When I say number of variables, you will see that in the last examples I gave earlier, we are only talking about a single variable. Like when I had the 4m minus 6 equals to 0, there's only a variable here, which is the variable m. So here now, what if we have more than a single variable? So that will take us to, just to have an hint of something we'll call function. Function. When we say a function, literally meaning, the meaning of function is the usefulness. That's the literal meaning of functional. But in mathematics, when we say a function is a rule. A function is a rule that assigns to every member of the domain a unique member of the codomain. A unique member of the codomain. That's a function. So where I say a member, I can say element. So we'll get to set theory, we'll be talking about that more. I can say to every element of the domain, it assigns a unique element of the codomain. Now, what do you mean by this? Let's look at an example of a function to explain that. If I have y is equals to 2x, y is equals to 2x. Now, this is a rule. There is a rule here. And what is that rule? Any variable x I pick, don't forget that x is a variable here, and which means that x can assume any number. Let me now give x some values. Let me say x is 1. Let me start from -1, 0, and 1. Let x be this. So the rule says that any element x I pick, I should multiply it by 2. So by so doing, when x is -1, y will obviously be -2. When x is 0, y will be 0. When x is 2, y will be 2. So you can see that every member here is assigned to one person here. -1 takes -2, 0 takes 0, 1 takes 2 in that respect. So that is what we call function. Though we have many types of functions, we just want to make use of that functions to explain the number of variables, how we classify element, equation, expression, and equality, the number of variables. Now, when we now have a function, we now have some types of function or some forms of function. We have functions that we call function of single valued function. and we have function of multiple valued function. We have multiple valued function, and we have function of single variable, and we have function of multiple variable. So I want to make use of these two majorly. But let me just explain what by single valued functions and multiple valued function. Now, if you look at this kind of function I just wrote earlier, single valued function, when I have y to be equals to 2x, we can see that here, if I change this y from being y and I say f of x, as a standard way of having a function, I can say h of x, I can say g of x. The f here is the function, which is the rule here. This x is called the argument of the function. It is called the argument of the function. That is what I want to apply the rule on. That is the x now. So if I say f of x equals to 2x, we know that any element of x or any number I assume for x, this f of x will only take an answer. For example, when x is 1, f of x will be 2. When x is 0, f of x will be 0. When x is 4, f of x will be 8. Now, so anytime, irrespective of the value we put in the domain or in the argument of the function assumes just a unique number. So anytime for a function, when we assume a number for the argument, the functions take only a unique number. It doesn't take more than a number. Then we say such function is a single valued function, just as this. But let's look at this function. The function f of x is equals to. So anytime we have a function that's, let's say we have f of x equals to root x. By definition of square root of a number is what number will be multiplied by itself twice to have the argument of that function x here now. So a square root always assumes two values, plus or minus. So here, when x is 1, f of x will be plus or minus 1. Why? If I multiply plus 1 by plus 1, I will have plus 1. If I multiply minus 1 by minus 1, I will still have a plus 1. So which means that the square root of 1 can either be plus 1 or minus 1. So again, with this same function, if x is 4, f of x will be plus or minus 2. If x is 25, for instance, f of x will be plus or minus 5. So you can see that using just a number for the argument of this function, the function assumes more than a value. So this is what we call multiple valued function. Now, but when we now talk about a single variable function, we are talking about these two functions. They are single variable. What do you call single variable function? A single variable function is a function that is fully defined by just its unique variable. Example of that function, well, let's look at the equation of a line. Y equals to mx plus c. Y equals to mx plus c. So if I take my m to be some values, let me say m is 2 and my c is 1. For example, the gradient is 2, the intercept is 1. I will have y equals to 2x plus 1, which is a function. Changing y to be some f, I can say f of x is equals to 2x plus 1. So this function alone, I can use it to draw multiple lines. I'll just make sure that those lines are having what I can use to locate multiple points rather. I'll just make sure that those points to got that line is having a slope. The line is having a slope of 2 and an intercept of 1. So I can put some values of x there. If x is minus 1, for example, f of x will be equals to 2 multiplied by minus 1 plus 1. And I will have f of minus 1 to be equals to minus 1. If x is 0, I will have f of 0 to be equals to 1. If x is 1, I will have f of 1 to be equals to 3. So with this single function here, I can see that I can locate different points. The first point is minus 1, comma minus 1. The second point is 0, comma 1. The next point is 1, comma 3 in that respect. So anytime a function can be fully defined by a single variable, we call such function of single variable. But we have some other functions that cannot be fully defined by a single variable. Example of such function is, let's say we have the volume of a cylinder, which is equals to pi r squared h. The volume of a cylinder, which is pi r squared h. Consider this function. I cannot say that this is f of r. That would be wrong. I can't say it is f of h. That will as well be wrong. Why? Because this function, this volume of the cylinder, the volume of the cylinder cannot be known by just knowing the radius without knowing the height. So if the radius is known and the height of the cylinder is known, I cannot know what the volume is. If the height is known and the rest is not known, the volume can also not be known. So what I can say for this function is to call it f of r and h. So that is, these arguments are what I will apply the rule on before I can know the volume of the cylinder. So that's what we mean by functions of multiple variable. So that is how we name equations, expression, inequality. So if we have equation, expression, let me just say equation and inequality majorly. You cannot have that for expression. If you have an equation or an expression that contains more than one variable, then we can call them simultaneous. You can call them simultaneous. So you can either have it to be simultaneous equation, or we have it to be simultaneous inequality. Example of simultaneous equation, we have x plus y is equals to 5, and we have x minus y is equals to 1. So this pair of equations is called simultaneous equation. Again, if you have it to be x plus 5 is less than or equals to 5, and x minus y is less than or equals to 1. This pair of inequalities can be called simultaneous inequalities. But don't forget that when we have more than one thing, two or more things, that they have something similar, we can call them system. We can call them system. So with that, I can call this simultaneous equation, I can call it system of equations. I can call it system of equations. Why this can as well be called system of inequalities. System of equations and system of inequalities. Now, again, why we don't have it to be that, we have it named system, we have it named simultaneous. We now also have to look at the properties of each of the entities in the simultaneous. So if both the first, the second, you can have more than, If both the first and the second equation are linear, I can now extend this name of the system and now call it system of linear equation. I can call it system of linear equations. On what condition? If the two equations are both linear, there is no variable whose power is more than 1, right? Why, as for this, you cannot call this one what? System of linear inequalities. Now, but again, if we now have one of them to be non-linear, probably it is quadratic. Example, if we have x plus y equals to 5, and we have xy equals to 6. So here, the power here is 1. The power here is 1, right? But here, the power here is 1 as well. The power here is 1. But there's a product of two variables here. So it makes this part of the equation to become quadratic. Another example, let's say we have that same x plus y equals to 5. We then have x squared plus y squared equals to 13. We have this to be linear and we have this to be quadratic. So when we have such a case where one is linear, the other is quadratic, and I'm now call it one linear, one quadratic. One linear, one quadratic. Mind you, it cannot be called system of linear equation again. Neither can we call it the system of quadratic equation. Either what do we call it? We call it one linear, one quadratic. But if both are quadratic, we have x squared minus y squared is 1. We have x squared plus y squared is 13. Then we can now call this one system of quadratic equation. I'll call it system of quadratic equation. So in our next video, we'll be looking at how do we now solve all these aforementioned types of equations, types of expression, types of inequality. So till we meet again.